Welcome to Streaming 101. My name is Josh Fisher. So, a little bit about me. I am the team lead at 1904 Labs here in St. Louis, Missouri. The project I'm working on is solving the problem with AI enabled customer solution services. So, helping companies scale out their customer service operations with bots, not people. I am Apache committer and PPC on the incubating project Heron, and I wrote a book. So, the agenda today is talking about what is stream processing at a very low level. We'll talk about a hello world solution, then I'll get into the code very briefly, at least how to use it. I've given this talk several times, and I used to have a board of use cases that would say like real-time data analytics, real-time data analysis, real-time this. And what it really boils down to is when you're using streaming systems, if you have a real-time need or a near real-time need, a streaming system may be a solution to your problem. So let's do some compare and contrast of some different services that are out in the wild today, right? So you have your typical backend service or API that's really it's like single threaded in a way. Well, maybe it's a single stage process, right? So the server's running all the time. It listens for requests. And then once that request is received, it's going to step through and it's going to create a handler to go off and handle that request in the API. Whether that handle is create, read, update, or delete, and then it's going to send back a response. So it's very single threaded in a way. Well, very single process. It starts, it goes and does something, it gives you a response. So then you look at batch processing systems, which are a little bit different. These are a little bit more complex than you looked at the API because you have you see processing stages here. We have incoming data that comes from storage, typically. And the batch processing system has a stage which will do something to the data and then stick that into another set of storage. Then your stages 2 and 3 will pull that data out, do something else, and stick it to another place of storage. Finally, your fourth processing stage of a batch job will pull data from that last set of data storage and then process that into the final stage. Similar to streaming or similar to batch jobs, streaming is very similar. It's just without those intermediate storage, right? So one of the nice things about batch is that you always have those intermediate stores in between steps. So if any failure occurs along the way, you can just kind of re-roll back and rerun those jobs. A downfall of the batch processing is that sometimes, based on a lot of legacy code, you'll see things are way behind. Batch processes run every 24 hours, 48, and getting the data that you need right now is really challenging, trying to maintain those older systems. So with stream processing, you're going to have similar things of stages, but really they're more of like components, right? So you have data that comes in. That data could be storage or a queue or something else. And then you have an executor that's going to pull that data out and it's going to do something to it. And then you have downstream executors that are going to pull that data off the upstream executor and do something with it. And then it's just going to keep repeating to the process. So if you look at, we talked about batch and we talked about stream, and these are really what we're going to focus on for this talk is, what are the differences? I think the main differences are these sets of storage that are sitting in between the processing stages within batch systems. These are where data sits at rest. And can really cause the delay in processing data over time. Now, the nice things about these batch jobs or these batch processing jobs or these streaming jobs is that there's multi-stages architecture that we're talking about, right? So each stage or step is a stage, or each step is a stage. So it allows you to add or remove stages as you feel, as you wish, based on some need, right? So with batch processing, a stage is going to go, it's going to do some data, it's going to put the data into storage, and then your next stage is going to pull from that storage, and it's just going to keep going down the cyclical manner. And the nice thing is that you can add as many instances in each one of these stages that are going to pull data in from a storage unit and then do something. And it really allows for a flexible way of maintaining applications. With APIs, this may be a little bit more challenging, but that's a whole nother story. I have a scenario that I put together in grokking streaming systems over the past few years that we want to talk about our hello world situation for streaming, right? So what the scenario is that we have a bridge and we got vehicles driving onto the bridge, and we have a sensor that's going to count that's going to emit the type of vehicle going over the bridge. And the reason for this is that the people who own the bridge, they want to make money. They want to show how many cars have passed over the bridge. Whatever the reason is, we want to find a way to catch those analytics in real time or a near real time way. So remember, if we talk about APIs, that's really that synchronous model, right? So you're going to send a request off to the API. It's going to do some processing. It's going to give a response. And on the other side, batch processing or streaming in this case, you send a request off and then the streaming job is just going to do something. You're not going to wait for a response. And in this scenario, this could really play up because our sensor doesn't need to know what happened to the event it sent off. It just needs to know that, hey, this thing was sent off somewhere, and then we'll show the result and assign elsewhere. So streaming in this case really makes sense, or at least event-based systems do, because we want to process data as it comes in, and we're not necessarily worried about we're not worried about getting the response at the sensor level. We're worried about getting the response somewhere else. So where a streaming system could fit in this scenario is reading off of the sensor, right? So the sensor is the external data source that is emitting events out into the wild, right? And then what we could do is we could set up something like an IoT sensor reader that could read events in from the sensor. They could do something to the data, or could just pass it straight into the job, which is typical. And then you have our vehicle counter, which is our component that could be counting the vehicles, the individual vehicles, whether it's car, truck, van, etc. Right, so get into there. There we go. There's something to bring up about streaming systems that are different than batch jobs. So we talked about batch jobs having intermediate databases or data stores in between those processing stages. Well, this is the same way with streaming, right? So there has to be some way to get data reliably from one component to the next, especially in the result of failures, right? And so what that is, that data store is a queue, or there's sets of queues in between components that downstream components pull from to get the next data event to do streaming on. And in this case, when we're passing events from the sensor, which we'll emulate here in a little bit, whether it's van, car, truck, etc., it's going to be populating those into intermediate queues, which are then processed by the components or the data sources and then moved on to the next. And really, this is just another view of what the data operation process looks like. So if you're looking, the way this diagram reads is a little backwards, but if you look at E1 over here on the right, this is the first data event that has entered the system, and it's going to enter in here from the right. And so what you see here are these intermediate queues that are connecting the data operation processes, which we could know as the components in a streaming job. This is a very, very low level view of what streaming jobs can look like. So there's some core concepts I've kind of talked about, but I want to recover here. So whenever you create a streaming job within a streaming system, whether it's Storm, Apache Flink, Pulsar, or Apache Heron, you're creating a job or a pipeline or a topology. And that pipeline or topology composes of the intermediate queues, the sources, and the operators within the job. Data sources are going to be components that read strictly from the outside world. So in our case, the sensor reader is pulling data from the sensor that's emitting it at the bridge, saying, okay, we're going to pump this data into the job. And then you have operators, and operators do operations on data. Operations could be join, filters, aggregations. The current operator we have in this job is counting events that are going through. So it's counting how many cars, trucks, or vans are crossing the bridge. And then the stream is that intermediate queue between the source and the operator that's connecting the two. So the source will be putting events onto the intermediate queue, and the operator will be pulling off all the events that were put onto that queue from the source. So to step back and get a little bit deeper into this job, so we have the job down below that we just saw, and that can also be known as the logical plane of the job. But then we have sources, and to get into the sources a little bit, the sources are ran typically by executors, and this is for lack of a better word, right? This is in a very generic way, so it can, depending on which framework you're using, they may be called something else. But those executors run sources that pull data from the outside world. So we'll have an executor in the streaming system that will run your implemented sensor reader source that will pull data at some timed interval, which is usually right away, which will run all your custom logic. And then we also have operator executors, which will run operators, right? So the abstraction is that these frameworks, they have executors for sources and operators that allow people to program their custom logic in with, they write it into hooks so that the streaming job can then hook in and then pull data, process it as you wish. and so forth. And then events are, again, the intermediate queues or the intermediate data elements in between. And then again, so we have our logical plan of the job. This just shows how data can logically flow from a source to an operator. And then the stream, again, is just the interconnection between the two. All right, let's get into the code. So my co-author, Ning Wang, has done a fantastic job of building out a code base for you to learn from. He's done it really well, so you can do it from Windows or you can do it from Mac. I'll be doing it from my Mac. But it's as simple as you just clone this. You clone the repo down. You do a Maven clean package as you look over here in Terminal 2, and then you run a Java command that'll run a jar for you, or it'll run a main class in a jar. And then in your first terminal, you can open up basically a listener on a port, and then we'll get the jobs running. And if all goes well, you'll see this nice little thing that says Javelin, and then Javelin is just a way to print out what the job looks like in your UI. And then I'm sure you're tired of hearing me look at slides. So let's get into actually what the code does. So currently you should see a browser that is dead because there's nothing running at the moment. So I'm gonna clear out this terminal. I'm gonna go up and I'm gonna start my little netcat tool on port 9990. And then I'm gonna start up my job over here in the right terminal with the Java command that I listed below, or listed before. The netcat terminal, this is going to be our emulation of what the bridge sensor reader is doing. It's going to be emitting events out into the wild. And then the terminal on the right is going to be actually running our streaming job. And then so everything worked as expected, luckily, because we're live. And then now you should, we've also have this little tool that'll help you visualize what the jobs look like. And so here you can see that we have a vehicle count job that has two components. It has a sensor reader, and then it has a vehicle counter. So again, over here on the left, we're going to emulate what that sensor reader does. So I'm going to just type in the word car, and we're going to say that this sensor reader shoots off the word car, or shoots off the word the vehicle type car. And the way we've programmed this job is that it's gonna have each component in the job print out what the data is that's processing. So in this case, the sensor reader, which is the data source of the job, it's pulling car out of the sensor. And then the vehicle counter component, which is the second one here, is counting. Okay, we found one car that has passed the bridge so far, so we have a count of 1. So if we do truck, same thing's going to happen. The sensor reader is going to pull truck in. The vehicle counter is going to take that data, which is a truck. It's going to count it and say, I haven't found any other trucks so far across the bridge, so we have a count of 1. And then if we did a car, the car count would be 2, truck would be 1, and then et cetera. And then we can go on and on and on with this. And this is the basic setup for how streaming systems work. And the reason we've done this in a simple way, and we've done this in a very lightweight way, because streaming systems can take up a lot of compute power and can be really compute intensive, and they can be very hard to learn. We've really stripped away all the heavy processing and made it as simple as possible so that people can get into this code and learn how the core concepts work so they can go use any streaming framework of their choice in the future. Now, the code base is hosted on GitHub right now. It's underneath my co-author's private account, Ning Wang, so Ning Wang TW/Grokking Streaming Systems. Code's out there and publicly available. It is full of documentation on how to use. He's done a fantastic job of putting this together, and we'd love for you all to check it out. So once again, my name is Josh Fisher. Thank you for your time. You can catch me here, Josh at joshfisher.io, or you can catch me on the socials at joshfisher.1108. Thank you.